This next example is in the category where we are approximating area. We're using rectangular approximation methods, we're using trapezoidal approximation, coordinate geometry, integration, finding exact area, maybe using a calculator. So these are some practice problems, just a couple of quick examples. So number one, use n equals 4 to approximate the value of the integral by the trapezoidal rule. And the integral that we are being asked to calculate is from 0 to 2 of 2x squared dx. So you may not know what this means, but maybe you know it as the area underneath the function and above the x-axis between the x values of 0 and 2 using 4 trapezoids. Now, it is definitely possible to do these problems without graphing at all, okay? And this is approximating area, so I'm not going to use an equal sign, I'm going to use an approximation. Out front, if you know the formula by heart, there is a 1/2 out front. There is also b minus a over n out front. Then there is an f of, in this case, there's going to be an f of 0 for the first term. Okay? I'm going to call it f of x sub 0 for right now to keep it a little bit more general, plus f of, 2 f of x sub 1 plus dot dot dot. It would depend on how many you have, plus 2 f of x sub, really I guess what it should be is n minus 1, and then plus f of x sub n. So if that makes sense to you, if you know what that means, good. I'm going to dive right into a bit of a algebra workout down here, and then I'm going to go ahead and show it with the graph as well. So b and a, what are they? So over here, a is equal to 0 and b is equal to 2 according to my integral right there. Here's my f of x right over here, and here is the number of trapezoids. So my 1/2 will be out there. B minus a is going to be 2 minus 0 over 4. 2 minus 0 is obviously 2, over 4 is a half, times another half, we're going to have out front 1/4. Here, f of, now where do these come from? In my head I know what they are. I know it's going to be f of 0, then I know the next one, this was a half. Okay, knowing what this was, taking a minute and knowing how big that was is going to help. So from 0, for my first a value, I'm going to keep adding a half until I hit my b value. So 2 f of a half plus 2 f of 1 plus 2 f of 3 halves, because that's really 2 halves, plus, now this is going to be 4 halves, which is 2, so I know I'm done, f of 2. Last, to get my answer, let's see if I could move that a bit, there we go. Okay, to get the answer, I'm going to evaluate now, so the 1/4 is out front. F of 0, we're going to get 0. F of a half, 1/2 squared is a 4th, 1/4 times 2 is 1/2, plus, plugging in 1 squared is 1 times 2 is 2, plus 3 halves squared is 9/4, times 2 is 9 halves, plus 2 squared is 4 times 2 is 8. I don't know if I have to keep putting these squiggles, but 9 over 2 plus 1 over 2 is 10 over 2, which is 5. 8 plus 2 is 10. 5 and 10 is 15. So 15 over 4. That's my approximate area. I guess depending on the question, you might call it, unit squared. You might just evaluate the integral and just call it 15 over 4. But why do I feel like I did maybe something wrong? Let me double check. I filled in 0. Good. 1/2 squared is a 4th. 1/4 times 2 is a half. 1 squared is 1 times 2 is 2. Oh, I know what I did. I was doing times 2 right here, but I'm not doing times 2 with these. My bad. So this times 2. I knew something seems a little off. Times 2 and times 2. So cleaning this up a bit, it's still 0 plus 1 plus 4 plus 9 plus 8. There we go. Okay, these numbers look better to me. And that's the 1/4 out front. That's 5. And 9 is 14 plus 8 is 22. 22 over 4 is 11 over 2. There we go. That looks more familiar to me. Okay, so I apologize. So right there, I have the area approximated using the trapezoidal approximation. Okay, just to recap what I did wrong, I was multiplying by the 2 out in front. I knew it seemed funny. I was multiplying by the 2 out front from there, and I felt like I was doing that too, and I wasn't, okay? So it happens. I'm not going to rewind or anything. It is what it is. So 11 over 2 is the numerical value for the answer, one way to look at it, and it's also 11 over 2 or 5.5 units squared if I'm actually going to kind of write it out as an area, but we're just approximating the value of the integral, so we don't need to put units squared. We could just leave it as 11 over 2. Now I'm just going to scoot this guy up a little bit. Let's see, should I leave it like that? Sure. Now I also prepared some graph for us to kind of look at it a little bit differently. So I can just sort of do like this. Now, the graph on the left is 1 unit, 1 box per unit, 1 by 1. If I graph out the parabola, the vertex is at 0, 0. Normally, we go out 1 up 1, out 1 up 3, out 1 up 5, out 1 up 7 to follow that normal x squared curve. Here, I have a vertical stretch of 2, so I'm going to go out 1 up 2 instead of 1, out 1 up 6 instead of 3. I would do another point, but it's going to be up pretty high, so I don't feel like squeezing and making a big mess, but 2, 4, 6. So my graph will look something like this. Now, I'm not having a good graphing day. Now, the area that I'm trying to approximate is the area underneath this parabola, and it is above the x-axis between 0 and 2. So that's going to be it right over there. And I'm going to break this up into 4 trapezoids to approximate it. And as you can see, it's a really narrow region for me to try to get a good view of. So that's why I redrew the graph to the right, and I kind of expanded it a little bit. I stretched it out. I did a horizontal stretch. Okay. Now, you could even figure out how much I stretched it by. If 1 unit was at 1 box before, and now look how much it's out. I did a horizontal stretch of 6, really, on my image so that I could get a better look at things. So I'm going to label the numbers that really are relevant here. Okay, and I'm going to plot a few points. So over 1, up 2, over 2 and up 8. Now while I'm at it, since I did mess up a few seconds ago, where is this? I had the 1/2 in there, I had a 2, and I had 9 halves. So, okay, here's the 0, here is the 1/2, the 2, next is going to be the 9 halves, so 4.5, and there's the 8. So if I carefully, let's see if I can do a little bit better now, less messy. If I stretch those parabola out, you're going to be able to see some details a little bit better. Just going to extend it a little extra. Okay, so this curve is now the stretched out version of this curve. What's good about this is it is going to make it a little bit easier for us to see. So this first trapezoid actually ends up being a triangle, but it is what it is. I'm going to exaggerate things a little bit, but there we go. Right there. Okay, this one was going right over there. Next. There's our third one. And the fourth one is right over there. Since the parabola is concave up, the teal side over here of the trapezoids should be above what I'm looking at, okay? Sorry, it got a little bit messy. Now, if I wanted to color these in just to get a better look at things, let's see what I've got here. I have yellow, I got a pink color. I guess I have orange and do I have a light green I just was using? Yes, there we go. Okay, so I have a few colors over here that I'm going to use, and I'm going to color in each of these shapes. I know I used pink. I probably shouldn't be using pink here, but too late. So there's my first trapezoid. My next one is right over here. Okay, and the next one. Sorry, a little messy. Right there. And in green will be the last one. Okay, so I have 4 trapezoids. According to n equals 4, I should be having, should have 4 trapezoids on my paper, okay? So if you think about how the trapezoids work, just quick review again, is if I look at, say, this yellow one, it's a right trapezoid if you turn it sideways, okay? So I guess, you know, here we go. here's my height, base 1 and base 2, right? Same idea here, right angle, height, base 1, base 2 of the green, base 1, base 2 of the orange, right angle, perfect height, and over here base 1 happens to be 0, base 2 is down here, and the height is right there. So it just happens to work out that when we try to do these trapezoid for one of the bases is 0, we end up with the area of a triangle anyway. So what is the area of a trapezoid? Hopefully we all know. 1/2 base 1 plus base 2 times height, or you could say the average of the bases times the height, whatever way you look at it. So this 1/2 is going to be in all of them, so I'm factoring that 1/2 out front. The same is the height. They all have the same height. The height is 1/2, so I'm going to factor that 1/2 height out as well. And then base 1 plus base 2. Well, base 1 is 0, plus base 2 is a 1/2, but here I'm going to have base 2 plus base 3. So it's plus a 1/2 plus 2. Now here it's base 3 plus base 4, so 2 again, plus 4.5, or 9/2, plus base 4 plus base 5, 9/2 one more time, plus 8. So out front I have 1/4, and if I add all this up, 1, 5, plus 9 is 14, plus 8 is 22. 1/4 of 22, same as 22 over 4, or 11/2. So I could use a graph to help me, alright? Maybe it makes it a little bit easier for you to set everything up. Whatever way you want to do it is wonderful. In this example, a question could just be posed slightly differently, where it just says something like, find the area of the shaded region. And a lot of times people automatically default to wanting to set up an integral. And that's not wrong. You know, you could set up an integral. This integral would be going from 1 to 3. The function looks like it is 2x plus 1 over here, dx. And if you know calculus, you know how to find the integral of that. So you know it's going to be x squared plus x. And you're going to evaluate that integral on the interval from 1 to 3, and then you're going to fill in 3 first, so we'll have 3 squared plus 3 minus, you're going to fill in the 1 squared plus 1, and that's going to be 9 plus 3 is 12 minus 2, and that gives me 10. So when you know calculus, you're going to do it the way that requires calculus. Over here though, this question would actually be given to students who don't know how to do this yet. And it's pretty simple. You just use area of a trapezoid. I guess you could break it up into a triangle and a rectangle. So let's do it both ways. If I look at it as just one big old trapezoid, okay, that means my trapezoid is sort of lying on its side. So the height is over here. So that means I'm going to have 1/2 sum of the bases times the height. So the first base, y value is 3, plus y value is 7, times the height is 2. The 1/2 and the 2 reduce down to 1, and 1 times 3 plus 7 is 10. Done. Same answer I got before. Well, what if we use a triangle plus a rectangle instead? So we could draw a line over here. Well, what's the area of the triangle? The triangle is 1/2 base times height plus, and I don't love this way, I think this is kind of amateur, but just to show you, you have options. You could always get it right. And then the rectangle is also, I'm not going to use base times height because depending how you look at it, I'm going to use that length times width. Okay? What does that give us? The base of the triangle is going to be 1/2. Base is 2 from 1 to 3. It's over here. And now the height is going from 3 as a y value to 7. So the height is 4. 2 times 4 is 8. Half of 8 is 4. Plus width and length, width, whatever, 2 times 3. What's 2 times 3? 6. And what's 4 plus 6? 10. Okay? So no matter which way you do it, a lot of times when you give problems that just require simple geometry, people tend to panic and forget when they've been doing integrals for so long, especially like when it's a semicircle. That's a really popular one. So always watch out for those semicircles and those simple, even with the absolute value functions, right? If you have the absolute value function, your area underneath, your area underneath is probably going to be triangular, okay? No matter which way you look at it, whether it's an absolute value function opening upward, opening downward, you're going to have some triangular shapes, so you're probably going to be able to just use a triangle to help you out. And again, to use a semicircle, well, the area of a semicircle is half the area of a circle, so it's 1/2 pi r squared, okay? So just be practical, think smarter, not harder.